Today we will be going over similar triangles. So just like with congruent triangles, there are shortcuts that allow us to tell if triangles are similar. The three shortcuts are AA, SSS, and SAS. So this stands for angle, angle, side, 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 and side, angle, side. So let's first take a look at angle, angle similarity. Angle, angle similarity tells us that if you have two triangles, where two angles of one triangle are congruent to two angles of another triangle, that tells you that these two triangles are similar. So let me write my statement. That triangle ABC is similar to triangle DEF. Next we have side, side, side similarity. Side, side, side similarity tells us that if we have two triangles, in order for two triangles to be similar, their sides need to be proportional, meaning we have to set up a proportion. The simplest way to do that is first you pick the shortest side of one triangle, and it goes with the shortest side of the other triangle. Set it equal to the middle side of one triangle over the middle side of the other triangle, and then the longest side of one triangle to the longest side of the other triangle. For these two triangles to be similar, the simplified form of these fractions should all be the same. 2/4 simplifies into 1/2, 3/6 simplifies to 1/2, and 4/8 simplifies to 1/2. Because all of these are the same, then yes, these two triangles are similar. So we have triangle ABC is similar to triangle DEF. The third way we can tell if triangles are similar is through side, angle, side. This tells us that if we have two triangles, where the two triangles have an angle that's congruent with each other, and side measures, we have to check their proportion again. So shortest side 3 over shortest side 6 equals longer side 5 over longer side 10, and check if those two fractions are the same. 3/6 simplifies to 1/2, 5/10 simplifies to 1/2. So we can say that triangle ABC is similar to triangle DEF. So the difference between SSS similarity and SAS similarity. SSS, you need to have all three sides proportional. However, SAS, if you only have two sides, but their included angle, the angle in the middle of those two sides, are both congruent, then we can just use two sides and check if they're similar. So check the proportion for similarity. Alright, let's do some examples. For AA similarity, you may see a question something like this, where you have two triangles, 60, 80, this is 80, and 40. So AA similarity tells us that we need to have two pairs of congruent angles. I can tell that this 80 is congruent with that 80. So we have one pair of angles. Now we don't know the other pair. However, we do know that all three angles of a triangle add up to 180. So what we can do is 80 plus 60, that's me 140. Then 180 minus 140 to get that missing angle. So that's 40 degrees. So now we can see that this bottom angle is congruent with this bottom angle. And since we have two pairs of congruent angles, we can say they are congruent. They are similar. I'll do another example and see what happens here. Okay. 80, 60, 60, 50. Okay. So same deal, when we have a missing angle, we have to check, are all three angles congruent? So I see this 60 is congruent with that 60. But do we know if this 80 will be the same as the angle over here? So we can check. 60 plus 50, that's me 110. I added these two angles together. 180 minus 110 gets me 70 degrees. That means up here 70 degrees. Once we see a pair of angles that's not the same, that's 70, that's 80, that's 50, that's 80. So these two, none of them are the same as the 80. That means not similar. For side, 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 I'm going to show you, whenever you have two triangles, you always have to check the proportions. 2, 3, 4. 3, 6, 7. So, the way we can figure out which sides are supposed to match is the shortest side of one triangle should go with the shortest side of the other triangle. So 2/3 equals middle side 3 over middle side 6 equals biggest side 4 over biggest side 7. And let's check, when we simplify them, this is 2/3, this is 1/2, this is 4/7. Once one of them is different from the others, in this case all three are different, all you need to be different is just one. Once one is different, that is no longer similar. Same deal for SAS similarity. So we have a pair of congruent angles that works. We need to set up our proportion. 3 short side over 6 short side equals middle side 5 over 8 middle side. When you simplify these, 3/6 simplifies to 1/2, 5/8 simplifies to 5/8, 1/2 and 5/8, they're different, which makes it not similar. Okay, last thing I would want to show you is how to use proportions to solve for a missing side. suppose we have this scenario where we have a building. Here's a building that's 10 feet. No, let's make it 30 feet tall. And it has a shadow of 50 feet. Similarly, we have over here a tree that has a shadow of 10 feet, and we want to figure out how tall the tree is. And we have the sun up here. Okay, so when you have two things making a shadow, we can actually make a triangle out of that. So there's your triangle. There's your triangle with the shadow. And these two triangles end up being, these two triangles end up being similar. Because they are similar, we can set up a proportion. The 30 of my building matches the x of the tree equals, going back to the building, the 50 of the building matches the 10 of the tree. So at this point, we can cross multiply to solve. 30 times 10 gets me 300. X times 50 gets me 50x. So we have 300 equals 50x. Then our last step, to divide by 50 to get me x equals 6. So this tells me that the tree is 6 feet tall. So there you have it. Here are the three ways to determine if triangles are similar. The types of questions we can ask when we ask you to show, are these triangles similar or not? And we can have problems associated with it, where if we know that the triangles are similar, or they told us the triangles are similar, we can set up our proportion to solve for x.